Hello and welcome to this presentation on bracket expansion. Within this presentation we'll consider such problems as a outside of a bracket and b plus c inside a bracket. This could be something like 5 outside the bracket and 2p minus 3q inside the bracket. And we'll also consider binomial types expansion where we have two brackets that are multiplied together, such as 2x minus 4, that's all multiplied by 3x minus 2. So let's consider problems that involve brackets and how to remove them. To remove brackets from algebraic expressions such as the a outside the bracket and b plus c inside the bracket, we basically multiply each term in the bracket by the outside quantity. So in this particular case, a is outside the bracket, so we'll multiply a by the first term inside the bracket and then a by the second term inside the bracket. So the answer here would be a multiplied by b added to a multiplied by c. Just remember that when there's no symbol between the variables, we assume multiplication. So we've got a multiplied by b here and a multiplied by c here. The method I'm using here is sometimes termed the crab claw method. So if you take the example of 2 outside the bracket here and x minus 4y inside the bracket, so in this case we would multiply the 2 by the x and then the 2 by the negative 4y. The answer here would be 2x minus 8y. 2 times negative 4 is negative 8. Just look at some illustrations here in algebraic terms. We've already said if a is outside the bracket and b plus c is inside the bracket, then we simply multiply the a by the b, and in this case we add it to the a multiplied by c. Notice a situation where we have a outside the bracket but b minus c inside the bracket. We still go through the same process of multiplying the a by the b, but notice in this case the positive a multiplied by the negative c will result in a negative ac. Just be careful of that sign change there. Taking the next illustration, we have negative a outside the bracket and b plus c inside the bracket. So again, multiplying the outside term by the inside terms, we get negative a multiplied by b, and then we get negative a multiplied by c. Again, be careful of the signs. And finally, we have a negative a outside the bracket, but we have b minus c inside the bracket. So again, expanding, we get negative a multiplied by b, and we add to this a multiplied by c. Just be careful there, we have a negative a here multiplied by a negative c here, and that gives us a positive ac shown here. Here's a few little illustrations of problems I've noticed students can have sometimes when dealing with brackets that have negative terms associated with them. If you take this first example, we have a negative x squared. Now that could actually be written as negative outside of the bracket and x squared inside the bracket. So what we've really got there is negative x multiplied by x. So taking the illustration below in numerical form, we have negative 4 squared, which is actually negative outside the bracket and 4 squared inside the bracket. So 4 squared is 4 multiplied by 4, and that's 16, but that will be negative 16 in this case because there's a negative outside the bracket. With this illustration here, we have a negative x inside the bracket that's squared. So this time we have negative x multiplied by negative x, and that will give you a positive x squared. So in numerical terms, having negative 3 inside the bracket, the whole bracket is squared there, that means we've basically got negative 3 multiplied by negative 3, and that gives us a positive 9 in this case. So just be careful of using brackets when we're squaring them, and the format of the problem we're looking at is the negative inside or outside the bracket, because it makes a difference to the sign of the final answer. Tutorial questions. This is worksheet 1. We're asked to simplify the following expressions. Question 1, we've got 2 outside the bracket, but we've got 3 add 4 inside the bracket. Now effectively we have like terms inside the bracket, so in this case we can simply add the 3 and the 4 together, value of 7, and then we multiply the 7 by the 2, and that gives us a value of 14. Likewise with question 2, inside the bracket we have 9 minus 6, so effectively like terms, just a constant, and it's all multiplied by 5. So I could write that as 5 outside the bracket, and inside the bracket 9 minus 6 gives us a value of 3. 5 multiplied by 3, a value of 15. I'll let you have a go at question 3. Same kind of thing. Simplify inside the bracket first and then multiplied by the number outside. Question 4, we now have some algebraic symbols included here, but they are nevertheless like terms. 2x added to 6x. So adding the terms inside the bracket, first of all, 2x plus 6x is 8x. And that's all multiplied by the 3 outside. So evaluating 3 multiplied by 8 is 24, so that's 24x. Question 5 is very similar. We've got like terms inside the bracket, so we can simply add them up and then multiply by the number outside. I'll let you have an attempt at question 5. Question 6 is slightly more complicated. Inside the bracket we have 2 terms, but they're not like terms. We have a 3x added to a 2y, so we cannot add them together. They are not like terms. So in this particular case we're going to have to expand the bracket like we did in the previous slide. So we're going to multiply the negative 4 by the 3x, and then the negative 4 multiplied by the 2y. So that will be negative 4 multiplied by 3x added to the negative 4 multiplied by 2y. Just be careful when you evaluate. Negative 4 multiplied by 3 is negative 12, so it's negative 12x for the first term. And we've got negative 4 multiplied by 2y, so that becomes negative 8y. Don't forget the positive and negatives there makes the negative. Question 7, we've got negative 5 outside of the bracket, 7a minus 4b inside the bracket. So again, they're not like terms, so we're going to have to expand the bracket. So negative 5 multiplied by 7a, and we're subtracting from that the negative 5 multiplied by the 4b. Evaluating that becomes negative 35a plus the 20b. I'll let you attempt questions 8, 9 and 10 shown here. Different symbols again. Notice the Greek symbols here, alpha and theta, but just take them as normal symbols. And see if you can expand the bracket and simplify the terms. The solutions to worksheet 1 are shown on the following slide. Here's worksheet 1 showing the answers for all the questions. Tutorial questions, worksheet 2. We're asked to remove the brackets in the following expressions. Questions 1 through to 20. I would encourage you to attempt these questions and expand the brackets as we did in the previous slide, using the same process in every question here. Just be careful with some of the questions. Question 4 has a fraction in it, half multiplied by the terms inside the bracket. So again, same process, but we've got a fraction outside of the bracket. Question 7 is slightly unusual with a negative sign outside. Sometimes students prefer to see a 1 in front of the bracket, so we've got negative 1 effectively when they're expanding the brackets. So that helps you then just add the 1 in front. I would encourage you to stop the presentation and attempt questions 1 to 20 and then review the answers on the following slide. Worksheet 2, answers, question 1 through to question 20. I'm going to work through a few selected questions on the following slide for your reference. I'm just going to work through a few questions for you. So question 3, we have 3 multiplied by the 3x plus 2y inside the bracket. So again, we're going to expand the bracket here. So expanding the bracket, 3 multiplied by 3x is 9x. And then 3 multiplied by the 2y is plus 6y. So question 4, we've got a half outside of the bracket, so it's half multiplied by the x minus 1 inside the bracket. Sometimes it helps if I write it in this format, the 1 upon 2 outside the bracket. Inside I've got x divided by 1 minus 1 divided by 1. As usual, we're going to expand the outside number with the terms inside the bracket. So considering how we multiply fractions, which we looked at in the previous video, we simply multiply numerators and multiply denominators. What you effectively get here is 1 multiplied by the x, so that becomes x, and 2 multiplied by 1 on the bottom line, and that becomes x over 2. We're subtracting because this is subtraction here, and we've got 1 multiplied by 1, so that becomes 1 over 2 multiplied by 1, That becomes 2. So x upon 2 minus 1/2 is the answer we're looking for. Question 7, we have negative outside of the bracket. As I said before, sometimes thinking of a 1 outside, so a negative 1 outside helps with the expansion. So we're going to multiply the negative 1 by a and the negative 1 by b plus b. So our solution will be negative 1a, or simply negative a, and negative 1b, or simply negative b. So the negative outside the bracket effectively changes the sign of all the terms inside the bracket. But if it helps you to think of negative 1 multiplied by the terms inside the bracket, then that's fine. Question 12, we're given negatives outside the bracket, and that's multiplied by inside the bracket 2x minus 5. So again, expanding the bracket, we have negative 2 multiplied by 2x, so that's negative 4x, and negative 2 multiplied by the negative 5, that becomes positive 10. Question 14, we've got 2k outside the bracket as multiplied by the k minus 5 inside the bracket. So again, expanding the bracket. 2k multiplied by k will be 2k squared from use of indices. Don't forget there's an index of 1 here and 1 here. So from indices, we did another previous presentation, that would be k squared. And then 2k multiplied by the negative 5 is negative 10k. Question 16, we have 3 terms inside the bracket, or multiplied by a outside. So again, we just take each of the terms individually and we multiply it by the a. So we have a multiplied by p, so ap, a multiplied by negative q, so negative aq, and a multiplied by negative r, negative ar. Just for reference, it doesn't matter if you've written that as pa minus qa minus ra. The numbers are commutative, so it doesn't matter which way around you write them, but conventionally we put the a in front of the p, as that's the alphabetical order. Question 18, we have 3x squared outside the bracket, that's multiplied by the 3 terms inside the bracket. So 3x squared multiplied by x squared becomes 3x to the power of 4, using our first law of indices. 3x squared multiplied by the negative 2xy becomes negative 6 x cubed y, and 3x squared multiplied by the positive y squared becomes positive 3x squared y squared. And finally, question 20, we have negative 2m outside the bracket and 3 terms inside the bracket. None of them are like terms here, so we just got to expand the bracket. So negative 2m multiplied by negative 1 is positive 2m. Negative 2m multiplied by positive 3m becomes negative 6m squared, again from our first law of indices, and negative 2m multiplied by negative 2n becomes positive 4nn. Tutorial questions, worksheet 2 continued. Again, we're asked to remove the brackets and simplify the expressions. This time we have question 21 through to question 30. Notice in question 21 we have 2 brackets here to consider. So we'll expand the first one, 3 multiplied by x and 3 multiplied by 1. And expand the second one, the positive 2 multiplied by x, the positive 2 multiplied by 4. So expand the brackets and then collect the like terms together. So we collect the x's together and collect the constants together to simplify. That applies to all the sums here. Don't forget with question 26 again about fractions, so it's a half multiplied by the y, half multiplied by negative 1 there, and a positive a third multiplied by 2y, and a positive a third multiplied by negative 3. Again in question 27, if it helps you to think of a 1 in front of the bracket, then add the negative 1 there. Question 27, we've got these 3 terms inside the bracket, but again the same principle applies. Multiply the outside number by the 3 terms inside individually. Question 28, we have 3 brackets here, but again the same procedure applies in each case. Just expand the brackets and then collect the like terms together. I would encourage you to stop the presentation and attempt questions 21 to 30. The answers are shown on the following slide. Worksheet 2 is the answers for questions 20 through to 30. A few selected questions are worked through on the following slide. In question 22 we've got two brackets here to expand, but we just simply expand the first bracket and we'll expand the second bracket in the way we have in previous questions, and we're going to collect the terms together. So equals to 5 multiplied by 2a is 10a, 5 multiplied by 4 is plus 20, first bracket dealt with. Second bracket, negative 3 multiplied by the 4a become negative 12a, and negative 3 multiplied by the positive 2 becomes negative 6. Notice we have like terms here, the 10a and the negative 12a. Don't forget the symbol in front of the numbers with it, so that's negative 12a. And we have the constants of positive 20 and negative 6. So bringing our like terms together here, 10a take away the 12a will be negative 2a, and the positive 20 take away 6 will be positive 14. If you have a positive and a negative term, it's preferable to put the positive term first. It's more of an aesthetic aspect to the question, but that would be the correct way to write the answer there. So 14 minus 2m. Question 26, we have a half outside the first bracket, so we're going to multiply the half by the y and the half by the negative 1. And the second bracket here we have a third outside, third multiplied by the bracket, so third multiplied by 2y, and the third multiplied by negative 3. So expanding the brackets as before, we'll basically get y divided by 2 minus 1 upon 2. Again, if it helps, you can think of these being upon 1. If it helps you, but you can think of those being upon 1. And then we get plus the 2y divided by 3 minus the 3 divided by 3. Simplifying on the next line, that becomes equal to y upon 2 minus 1 upon 2 plus the 2y upon 3, and then minus 1. 3 upon 3 of course is 1, so minus 1. Again, looking at the like terms, I have y upon 2 and the positive 2y upon 3, the like terms, and my constants negative a half and negative 1. So I could write the equation now as y upon 2 plus 2y upon 3, and put the constant at the end. That would be negative 3 upon 2. That's 1.5 is a top-heavy fraction. So as these two terms have effectively been added together to produce the negative 3 upon 2. I'm now going to use fractions to bring these two like terms together. Now, common denominator for 2 and 3 is 6, so I can write them both over 6. How many times does 2 divide into 6? It divides 3 times, so I multiply the y by 3, so that's 3y. I'm adding to that. How many times does 3 divide into 6? 3 divides into 6 twice, so I multiply the numerator by 2, so that's plus 4y. I've still got my negative 3 upon 2. But now I can simplify finally to 3y plus 4y is 7y upon 6 minus 3 upon 2. So the expansion of brackets in that particular question was the initial part of the question, but there's quite a bit of work to bring the like terms together to get the final answer shown here. Question 27, we've got negative outside the bracket here of 4a plus 5b minus 3c, and we've got negative 2 outside the bracket of 2a plus 3b minus 4c. Again, we're going to expand the brackets, as we have in previous questions, and also you want to think of that as being negative 1 if that helps you, and write the negative 1 there. So expanding, negative 1 multiplied by 4a is negative 4a, negative 1 multiplied by 5b, negative 5b, and negative 1 multiplied by negative 3c will become positive 3c. So again, the negative sign outside the bracket changes the sign of all the terms inside the bracket. Expanding the next bracket, negative 2 multiplied by 2a becomes negative 4a, negative 2 multiplied by positive 3b becomes negative 6b, and negative 2 multiplied by the negative 4c becomes positive 8c. Okay, looking for like terms here, I've got a negative 4a, got a negative 4a here, I've got a negative 5b here and a negative 6b here, and I've got a positive 3c here and a positive 8c there. So those are my like terms. So on the next line, bringing them together, negative 4a, and take away 4a is negative 8a, and negative 5b, take away 6b is negative 11b, and finally positive 3c, add 8c becomes positive 11c. Question 28, we've got 2x outside the bracket multiplied by x multiplied by negative 5. Second bracket we've got negative x multiplied by x and negative x multiplied by negative 2, and the third bracket negative 3x multiplied by x and negative 3x multiplied by negative 5. Expanding, 2x multiplied by x, 2x squared, 2x multiplied by negative 5, negative 10x. Second bracket, negative x multiplied by x is negative x squared, and negative x multiplied by negative 2 is positive 2x. And finally, negative 3x multiplied by x is negative 3x squared, and negative 3x multiplied by negative 5 is positive 15x. Again, my like terms, I've got a positive 2x squared, a negative x squared, a negative 3x squared, and I've also got a negative 10x, a positive 2x, and a positive 15x. So looking at the x squared terms, I've got 2x squared minus x squared minus 3x squared. That gives me negative 2x squared. Looking at my x terms, I've got negative 10x, positive 2x, positive 15x. So that gives a value of positive 7x. Again, we should really write the positive term in front of the negative term, so it's 7x minus 2x squared. I'll leave you to review the remaining questions. We're going to now consider slightly more complicated bracket expansion problems. We're going to look at the products of two binomial expressions. So the product of two binomial expressions is outlined as shown below. So if we have a plus b in a bracket, that's a one binomial bracket, two terms in it, and we're multiplying that by c plus d as our second binomial bracket. Don't forget we're multiplying the brackets, there's no symbol between them, so we assume multiplication. Sometimes large dots are used for multiplication. So now we have two brackets multiplied together. The expansion is slightly more complicated. We've got to multiply the a by the c, shown here, and then the a multiplied by the d, shown here. Then we've got to multiply the b by the c, shown here, and finally the b multiplied by the d, shown here. So looking at example 1 below here, we've got 2x plus 5 in one bracket, and that's multiplied by, in the second bracket, 4x plus 3. So our expansion will be 2x multiplied by the 4x, shown here, and 2x multiplied by the positive 3, shown here. Then we have 5 multiplied by the 4x, shown here, and then 5 multiplied by the positive 3, shown here. So 2x multiplied by 4x is 8x squared, and then add the 2x multiplied by 3, which is the positive 6x, and add the 5 multiplied by 4x, which is positive 20x, finally add the 5 multiplied by 3, which is the 15. Again, notice we have two like terms in the middle, the positive 6x and the positive 20x. That's how we obtain the positive 26 here in the middle term. So the final solution for the expansion of the two binomial brackets shown in example 1 is 8x squared plus 26x plus 15. Just for reference, the method we're using to find the products of two binomial expressions is sometimes called the crab-claw method, as you can see from the outline here below. Here's 3 more examples that you may want to work through at your own pace. I'll leave them on the slide for a moment. Again, the same procedure in all questions. The way we expand the brackets doesn't change, but I'll let you stop the presentation and think through the expansions for yourself. Notice that using this method we always end up with these like terms here in the centre of the expansion. Tutorial questions, worksheet 3 shown here. We're asked to find the products of the following expressions. Question 1 through to question 12 here. Same expansion required as in the previous work for every question. I would encourage you to start the presentation and attempt these expansions. Tutorial questions, worksheet 3 continued. Asked to find the products again of the following. This is questions 13 through to question 22. And again the expansions are as shown on the previous slide. I would encourage you to start the presentation and attempt these questions. The answers are shown on the following slide. Worksheet 3, answers are shown here for questions 1 through to 22. Just going to work through a few questions from worksheet 3. This is question 6. In the first binomial bracket we have 5x plus 1 and we're multiplying that by x plus 4 in the second bracket. Again we're using this crab claw type technique. So expanding, we get 5x multiplied by x is 5x squared. 5x multiplied by 4 is positive 20x. And we get 1 multiplied by x, so that's positive x. And then 1 multiplied by 4, so positive 4. Two like terms in the middle. So we're going to add them up. So simplifying, we get 5x squared plus 21x plus 4. Question 17, we've got 3x minus 1 multiplied by 2x minus 5. Again, expanding the brackets with the crab claw method. That's equal to 3x multiplied by 2x, that becomes 6x squared. 3x multiplied by negative 5, negative 15x. And then negative 1 multiplied by 2x, that's negative 2x. And then negative 1 multiplied by negative 5 becomes positive 5. Then noting the like terms in the middle here, that's equal to 6x squared minus the 17x plus 5. Question 22, 2x plus 5 multiplied by the x minus 2. So again expanding. 2x multiplied by x is 2x squared. 2x multiplied by negative 2, negative 4x. 5 multiplied by x, so positive 5x. And 5 multiplied by negative 2, negative 10. Again, noting the like terms in the middle. So simplifying, we get 2x squared plus 1x, or simply x, minus 10. Tutorial questions, worksheet 3, continued. Again, the same approach required in all of the questions. Notice in question 34, x plus 1 all squared actually means x plus 1 in brackets multiplied by x plus 1 in brackets. And the expansion is as before. Worksheet 3, here are the answers, questions 23 through to 34. Question 30, we've got 3v plus 2u multiplied by 2v minus 3u. So expanding the brackets, 3v multiplied by 2v is 6v squared. 3v multiplied by negative 3u is negative 9uv. And 2u multiplied by 2v is positive 4uv. And 2u multiplied by negative 3u is negative 6u squared. Again, having like terms in the middle, equals to 6v squared, and our negative 9uv plus the 4uv is negative 5uv and then minus 6u squared. And I've also shown these solutions to question 33 and 34 for your reference. To finish off with, we're going to look at the square of a binomial expression. The square of a binomial expression is the sum of the squares of the two terms and twice their product. So for example, if we have a plus b all squared, that really means a plus b multiplied by a plus b. Expanding the brackets, we have a multiplied by a, which is this a squared term here, a multiplied by b, this term, then we'll have b multiplied by a, this term, and then b multiplied by b, this term. Simplifying, we've got a multiplied by a, which is a squared, then we have a plus ab and a plus ab, so that becomes plus 2ab, and finally we have a plus b squared. In other words, expanding a plus b all squared, we have the sum of the squares here, and we have twice their product here. As we turn into question 24, we had x plus 1 all squared. We end up with the sum of the squares shown here, so x squared and 1 squared, and then twice the product. So the product is x multiplied by 1, so that's 1x. We have twice the product. Example 6, 7 and 8 show further examples of this situation where we're squaring the bracket. So 2x all squared becomes 4x squared, and the positive 4 becomes positive 16, and then we have twice the product. So 2x multiplied by 4 would be 8x, multiply that by 2, positive 16x. Consider example 7, we have 3 theta minus 2 all squared. So again we have the sum of the terms squared, so 3 theta all squared becomes 9 theta squared. Negative 2 squared becomes positive 4, and the product of 3 theta multiplied by negative 2 is negative 6 theta, but we have twice the product in the solution, so negative 12 theta. And finally, example 8, we have 2p plus 3y all squared. So again, we have the sum of the squared terms. 2p all squared becomes 4p squared. And positive 3y squared becomes positive 9y squared. And then multiplying the 2p by the 3y, we have 6py. So we have twice that in the answer of positive 12py. And finally, if we consider the product of the sum and difference of two terms, so in this case we have a plus b multiplied by a minus b, and when we expand the brackets, again using the crab claw method, we find that the answer simplifies to a squared minus b squared. So the result of the binomial expansion is the difference of the squares of the two terms. So in example 9, we're given 5x plus 3 multiplied by 5x minus 3. So our solution will be 25x squared, that's the 5x squared, and we're subtracting from that the 3 multiplied by 3. In example 10, we've got 2p plus 7y, all multiplied by 2p minus 7y. So again, the solution will be 2p all squared is 4p squared. Subtracting for that, we have 7y squared, so that becomes 49y squared. Subtracting 49y squared. So worksheet 3, final questions, 35 through to 48. So in question 35, we have the square of a binomial expression, and that's the same approach required for all questions up and through question 44. In question 45 through to 48, we have the products of the sums and differences of two terms. We have two brackets, but we have different signs within the brackets. I would encourage you to start the presentation, but the answers are shown on the following slide. Worksheet 3, here are the answers for questions 35 through to 48. A few word solutions now. Question 35, we have 2x plus 3 all squared, so we know the solution will be of the format of square of the 2x, so that's 4x squared, twice the product, so 2x multiplied by 3 is 6x, so that's plus 12x, and then the 3 squared, so that's plus 9. Question 39, we have 2x minus 3 all squared, so our solution will be 2x all squared, that becomes 4x squared. The middle term is twice the product, so 2x multiplied by the negative 3 will be negative 6x multiplied by 2, that becomes negative 12x. And then the negative 3 squared is positive 9. Question 41, we have x plus y all squared. So again, following our pattern through, we will have square of the x, so x squared. The second term is twice the product of these two terms, x and y, so x multiplied by y, and that's multiplied by 2, so plus 2xy, and then plus the y squared. Question 43, we have a minus b all squared, so our solution will be the first term squared, so that's a squared minus twice the product, so ab is the product, so it's twice ab, and then we add in this case the second term b squared. Question 45 here is the product of the sum and difference of two terms, so expanding we will get square of the first term, so that would be 2x all squared is 4x squared, and then we get the square of the second term, so that will be minus the y squared. In question 47, again we have the product of the sum and difference of two terms, so that equals 2, so we square the first term, the 2m all squared is 4m squared, and we minus the second term all squared, so that's minus 3n all squared is 9n squared. I will let you work through the rest of the solutions at your own pace. Here's the bibliography used to help generate the presentation. And I hope this has been of use to you, and thank you for viewing.